Okay, so in this video, we are going to focus on the mechanism. So first, this is SN1 mechanism. Remember in the previous video, we already know that SN1 mechanism involves two steps. So step 1, okay, is the formation of carbocation, or usually carbocation I just simply write C+. Okay, this formation of carbocation. So let's see the example. So let's say if we have this kind of haloalkane, okay, this kind of haloalkane. So first step is the formation of carbocation. So remember, this is a tertiary haloalkane. How do we know? Because this is our alpha carbon, and this alpha carbon attached to 3 other carbon, right? Okay, so tertiary haloalkane. Okay, so the mechanism would be, this is the polar bond, partially negative, partially positive. So first we will have the heterolytic cleavage, where this bonding will be break and the electron will goes to the Cl, because Cl or chlorine is more electronegative than this carbon. So what happened when the bond breaking? So this is slow step. What happened here is this carbon chlorine bonding is broken. Okay, so carbon will be positive because this electron from the bonding goes to the Cl. It's like the carbon donate its electron to Cl, so it's become positive. So the rest of the atom here will be written. And what happened to Cl? Cl gain the electron from the bonding, so Cl will become Cl minus. Alright, so we can see here, you have to determine the stability of this carbocation, or the class of this carbocation. So see the C plus here. So look how many carbon, other carbon that is attached to 1, 2, 3. So basically this is tertiary carbocation. Remember, we just discussed in previous video that tertiary carbocation is the most stable. So because we are forming a tertiary carbocation, so definitely this will be SN1 mechanism. Alright, so step 2. So now step 2 is the nucleophilic or nucleophile attacks the carbocation. Okay, nucleophile attack the carbocation. So wait, sorry about that. I just want to remove a little bit over here. Alright. Okay, step 2, nucleophile attacks the carbocation. So we take the carbocation that we formed in the first step just now. Okay. This is the tertiary carbocation. Remember, SN1 mechanism need the most stable carbocation, okay, to make it happen. Okay, so now the nucleophile, I just write Nu negative here, it will attack the carbocation. Okay, remember in our previous lecture, right, in DK1, I always said that nucleophile always attack the electrophile. Okay, so this is the electrophile. So what happened in this reaction? So this will be fast reaction, okay, because the carbocation is stable. So the C will make new bond with the nucleophile, okay, and the rest will be written. Just write back CH3, CH3, CH3. So that will be the product. Right, so that is SN1 mechanism. Okay, first we form the carbocation, and we should form a tertiary carbocation for SN1 mechanism, and then followed by step 2, the nucleophile will attack the tertiary carbocation to form the product. Okay, to form the product. Okay, so now for SN2 mechanism, I'll show you I'm sorry about this. I just want to move a little bit here. Okay, for SN2 mechanism, okay, SN2 mechanism, okay, so you should see the difference between these two types of mechanism. Okay, so remember in the previous video, SN2 mechanism only involve one step. Okay, and for SN2 mechanism, you should draw the haloalkane in 3D form. Okay, in the 3D form or 3D structure. So I just put like CH3 here. So because this is an sp3 carbon, remember sp3 carbon, so the 3D of sp3 carbon, that will be like this tetrahedral. Okay, this is a tetrahedral. So let's say this is hydrogen and hydrogen. Okay, so remember for SN2 mechanism, okay, how the mechanism works is the nucleophile will attack from where? From back side. Remember, it attack from the back of the carbon here, from the carbon chlorine bond. It attack from here, from the back. Okay, not from the front. It will attack from the back. That is how SN2 mechanism works. So here we go. We have nucleophile here. It will attack from the back side of the haloalkane of the carbon chlorine bonding. Okay, the back side. So what happened here? When the nucleophile try to make a new bond to this carbon from the back side, therefore this carbon chlorine is breaking at the same time, simultaneously. Okay, nucleophile attack carbon from the back side, so carbon chlorine will break at the same time or simultaneously. So what happened here? So this will be a little bit slow reaction. We will form an intermediate here, intermediate or an activated complex. So when this nucleophile try to make new bond with carbon, so this is partially bonded. Okay, partially bonded. This is like dotted line here because it is partially bonded, while the carbon chlorine will be partially broken. Okay, so this is called, oh, not finished yet. So this hydrogen and this hydrogen will be at the center like this. Okay, so this is called a transition state. Okay, and therefore after that, okay, we will only form the product. Okay, the product will be like that. So finally carbon chlorine will be break and nucleophile will form bonding with the carbon like that. Okay, so the hydrogen here will be like this. Oh, I'm really sorry, you didn't see that. Oops, it's like this. Okay, nucleophile attack from the back side of the carbon chlorine bonding. So at the same time, carbon chlorine will be break. So we will form an intermediate. Nucleophile partially bonded to this carbon. So this is dotted line because it is partially bonded, and the carbon chlorine is partially broken. Okay, also dotted line. And what happened to the CH3 and 2 hydrogen here? Okay, CH3 and 2 hydrogen here, when it become an activated complex like this, or this is at the transition state. So this carbon will be, sorry, this CH3 will be at the center, and this 2 hydrogen also at the center. Okay, and then finally the carbon chlorine will be break, and nucleophile now will make a complete bond with the carbon. So this is the new bond, and when the carbon chlorine is breaking, right, so this carbon and this CH3 will be like this. Okay, it will move to the, it's like to the right. Okay, we will form this kind of product. So what happened to the chloride ion just now? It will become Cl minus. Alright? Okay, so hopefully you can see the difference between SN1 and SN2 mechanism, and we will discuss more on these two mechanisms during our lecture in DK1. Bye bye.